A basic introduction to propositional logic. Demonstration 8.1, full table. The table rules using the terms P and Q. Not P flips the truth value. P or Q, notice that only one has to be true. P and Q, notice it's mostly false because even if one of them is false, the conjunction will be false. P arrow Q, it's always true except the only case that arrow is false is when true leads to false. So if you have true going to false, that will be false. And then the double arrow where both of the terms have to match truth values, whether they're true or false, but as long as they match. Problem 115. A double arrow B, B double arrow C. Conclusion, therefore A arrow C. Step 1, check how many terms you need. In this case, you have the letters A, B, and C, so you have 3 terms. Step 2, set up your table. So based on your terms for a full table, you'll need 2 to the nth number of rows to test for all possibilities. In this case, there will be 8, right? 2 to the third is 2 times 2 times 2, 8 rows. So each row starts with true and false, and it rotates exponentially to accommodate all possibilities. So for A, you start with true, false, true, false, true, false, true, false. Then for B, you have true, true, false, false, true, true, false, false. For C, you have true, 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 false, 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 false. This matrix will give you all the truth possibilities for these letters and every combination of them. So after you set that up, that's just standard for any 3 letters that you have. Skip a column and put your argument there, right? Put your premises in separate columns, right? Keep the turnstile symbol to show that that is the conclusion. Step 3, calculate the values. So using A, B, and C, and the values that are listed there, use the rules that we learned before to calculate the truth values. So the table rules connected to not, or, and, arrow, and double arrow show your work and final answers. Some truth table calculations can be long, so you might want to use like small t and small f and stuff, and then give your final answer as true or false. In this case, it's pretty simple. For the first column, A double arrow B, remember, the double arrow rule is that they just have to match. So when A is true and B is true, you'll have true. What about the next row? A is false and B is true, they don't match, so it will be false, right? And continue on down the line. Same thing for B double arrow C. Use the columns that show the table values for B and C. Okay, what are the truth values? And evaluate them. Do they match? Because you're trying to look at double arrow, right? Which means they have to match in order to be true. The final column, which is the conclusion, has A arrow C. Now remember, that is always true unless there is true going to false, right? So look at A and C. The value for A is true in the first row. It goes to true on the first row for C, right? So that will be true. The second one, false to true, that's still true because that's how arrow works. What about true to true on the third row? Also true. False to true, also true. The first time you hit a false on the A arrow C column, past the halfway mark, when you have the 5th row that says true to false, that's the first time you get the false result, right? Because that's how arrow works. It's always true unless true leads to false. Okay, so to recap, double arrow, the values have to match. For arrow, it's always true unless it goes from true to false. Okay, the next step is to check for validity, because what we're doing with truth tables is trying to find out if this is a valid argument or not. A valid argument is one where the conclusion cannot be false if the premises are all true. So all you have to do is check if any of the rows have all true premises, right? We're not concerned with the other rows. Notice the rows that are not highlighted. Why are we not concerned with those? Because they don't have all true premises. How many premises are in this argument? 2. And which ones show that they're all true? Only the first one and the last one, right? Every other row shows a combination of true and false. Now that you know the first row, the last row, you have all true premises, right? Both of them are true. Then you check those conclusions. Are any of those false? No. In this case, the first row, both of the premises are true and the conclusion is true. The last one, same thing, right? So the argument is valid. In other words, you checked every single truth possibility for A, B, and C, and you never found a case where there was all true premises and a false conclusion. Therefore, it is a valid argument. Here's the final answer. You want to keep all your table calculations and you want to show which rows are the test for validity, right? So you want to keep that you tested the first row and the last row showing that these are the ones that have all true premises and that none of them had a false conclusion. Then you want to state your judgment that it is indeed a valid argument.